Welcome back to the machine learning course using Python, and we are in the color classification part 2, that is the module 4, the fourth lesson in the module 4. We are doing random forest. We are continuing with random forest, and the title of this topic is grid search for parameter training. Remember, we have been assigning the various parameters like n estimators, Gini, or entropy, and so on. But there's a way of finding out the best parameters for the random forest. That technique I'm going to teach you in this lesson. So that methodology is called grid search. We do a grid search for optimal parameters that will give the least errors. I told you in the beginning of lesson 4, the idea is to get minimum errors, optimal errors, okay, minimize errors. So we will do the grid search to get optimal parameters. That will give us the least errors, okay. There will be error, but we want to minimize it. So to configure search and with tunable parameters of a decision tree or random forest, we can use grid search CV from the sklearn library. In fact, I'm going to teach you only the grid search for random forests, but you can also do it for decision tree, the same algorithm, and I leave it as an exercise for you. So you can, after the end of the lesson, you can try choosing for getting optimal parameters for decision tree, which we discussed in the lesson 1 and 2. But I will demonstrate to you for random forests. So grid search CV is the library, sklearn library. It's a very powerful library. It allows us to define grid of parameters to search over and performs an exhaustive search for the best combination of parameters. Where the number of parameters, these are 6-7 parameters for each random forest. So it will you do exhaustive search and find out those parameters by actual experimentation, which will give us the minimized errors. So I have taken 2 examples for this. One is the customer churn data set. So this is how I specify in the grid search CV. I said param grid is equal to. So this is the choice I am giving to the program to experiment with the estimators 50, 100, or 200. And criteria can be Gini or entropy. The depth can be none or 5 or 10. So these things I give, and with this data, our algorithm will try to find out the best or optimal parameters. And the result I got of for the customer churn data set is given here. So the best parameters, criterion Gini, max depth is 5, min sample leaf is 1, min sample split is 2, and n estimate is 50. And the best score is 0.87. And once you substitute this and make a random forest, you substitute these parameters, you will get an accuracy of 0.916. Okay, you need not check it again, but I will give one example which will check whether it's correct or not. Okay, and the next is I use the ID data set. I repeat the same thing. I give various options, and I allow the program to find out and give me the best parameters. So it gave criteria Gini. Gini gives the best parameter, best type, and max and depth is none, min sample is 2, and n estimate is 100. In the previous case, it gave 50, here it gives 100, and the best score was 0.958. And when I use these parameters, I'll get an accuracy of 1.0. That's the beauty of this. And lastly, I'll take an example of regression. random forest regression using Guinea. So what you have to import? For Skeleton ensemble import random forest regression, and you say regression is equal to the same thing, random forest regression, n estimate is equal to 100, random state is equal to 0. If you give that, it will give you the regression. So we will see all this using a Jupyter notebook. So let us look at the first example. Okay, these are calling the N4. So grid search for optimal parameter. I'm using customer churn data, importing libraries, same libraries. Then the data set I'm using is customer churn, and the head is like this. And you have to assign X and Y, which I do it here. Okay, X and Y are printed, 5 values. Then I split the test training in the test data set. I get this. Okay, so I have done this. And if I implement it, it's going to take a lot of time. So I have already done this. I'll show you the results. It estimated what are the optimal parameters. I'll show you this. If I do it again, it's going to take a lot of time. And for 3-4 parameters is like that. So I will show you the results I got. You can do it yourself and see also. It takes a lot of time for getting these optimal parameters. Actually, doing it, that's why it's taking time. It's not the old report. It currently is doing it. And you will get the optimal parameters shortly. It's doing it still. We can revisit and so I'll show you. I'll revisit and show you. In the meanwhile, I'll take the next example. It'll take a lot of time, okay? That is N5, where I'm going to use here. I think the results are already available. It's available, I think. Here. Yeah, here the results are available. Okay, let me explain to you. In the same grid search for another data set, that is IRI data set. So import the algorithm, import the libraries. This is the IRI data set. Oh, sorry, I didn't do it properly. I shouldn't be in a hurry. Now I won't get it. I'd implement. No? These are the heads. This I did not execute, but I'm executing it. This is very important. X and Y I'm assigning. And then dividing the test and training data sets. And here is the grid search. So I get run for this classifier and define the parameter grid, estimators, criterion, all that, and I do the perform grid search. Okay, and then grid search fit X train, Y train, and they get the best parameters and the best score. Okay, based on the best parameters, I can evaluate the best model. That is, you do it again, the same parameters you get, you will get the test accuracy that's got here. And for this, I have already done it. I don't want to execute it now and make you wait. So I'll show you what result I got. The best parameters for these, Guinea, maximum depth was none, min sample leaf is 2, min sample split 5, N distribution 100 and the best score of 0.95, and I got a test accuracy of 1. Great. Okay. So to confirm that it really works, I'll give these parameters and build a random forest classifier. Okay. Second view. So I copy those parameters, okay, and substitute here graded Guinea and all this min sample 2, and you will find at the end of it the number of estimators, n estimators will be 100, right? So I can execute this and show you, and you will get the accuracy of 1, which you got earlier. See? So you got accuracy of 1, and you can get a confusion matrix. You will get like this. If you want, you can do those also. So it confirms that whatever results given while getting the best parameters holds. So here I didn't do grid search. I substituted the parameters and found the accuracy to be 1. That 1 is a very good accuracy. Let us see what happened to that, we're executing the churn database, right? Got it. So it gave us, after this time, it gave criteria Guinea, maximum depth 5. So what I'm doing, you understand? And we were doing it and it was taking time, so I went to the next one. So now we come back to the same notebook. So, and it prints the parameters, Guinea, maximum depth is 5, minimum sample leaf is 2, and so on. N estimate is 100, and accuracy is this, and best accuracy, test accuracy 0.9. If you substitute these values and do the random forest, you will get only this much accuracy. Okay, and the last one, I'm going to use the random forest as for regression. So only two lines you have to change, nothing else. So I'm going to use random forest regression. I'm using the customer churn database, and I can print the head and inner print also. But I had to assign X and Y. Then I split. So now regression. So I had to import random forest regression and the mean squared error and R square error score. Then regression, random forest regression, n estimate is 100, random state is equal to 0. So regression fit, extend, wait time, that's all. Only 2 changes I make for regression. Or rather, yeah, two changes. And fit is there anyway in classification also, Y prediction. So now you draw this. So you get mean square error of 0.067 and R square of 0.4342. So let us recall what all we have done in this lesson. I explained to you what a grid search algorithm, and we use it to find out the optimal parameters. With those optimal parameters, we try to find the optimal parameters for 2 data sets. And after the grid search, it gives you the optimal parameters, and it also gives you the classification. But also you can get it. It also gives the test accuracy. So we confirmed it for one of the cases. We confirmed it for the IRI data set. We confirmed it. We chose those parameters, substituted it in our classification program, and then we confirmed we got the same accuracy, right? And then I explained to you what is a randomity regression. That's all for now. Until we meet again. Bye bye.